In this session, I am going to discuss the practical based on circular convolution for the subject digital signal processing of third year ANTC students, semester 1. Aim of the experiment is write a program to find 4-point circular convolution and compare the result with 8-point circular convolution to study aliasing effect in time domain. First of all, we'll discuss what is convolution. So basically systems are described by a signal called as impulse response. Impulse response means the response of a system when impulse is applied as an input to the system. Convolution is important because it relates the three signals of interest. First is input signal, second one is output signal, and the third signal is impulse response. Because output of a system is nothing but convolution between input signal and the impulse response. If we know the system's impulse response, we can calculate the system's output for any possible input signal. That is the significance of convolution operation. Then linear convolution is not possible if both the input signals are periodic. For this reason, we calculate periodic convolution in such situation. If both the signals, input signal xpn and impulse response h suffix pn are periodic with identical period of capital N value, then their periodic convolution generates a convolution result y of n that is also periodic with the same period capital N. The periodic convolution or circular convolution between xpn and hpn is denoted by the notation y suffix pn, and it is given by the formula like this: y of n, p stands for periodic, is nothing but circular convolution between input signal, which is periodic, xpn, and the system's impulse response, hpn, which is also periodic. And that is given by the formula summation between xpn multiplied with hpn minus k, where k is varying from 0 to n minus 1. Here, the input signal and impulse response terms can be interchanged. After interchanging also, we will get the same resultant y of n. Now, if we verify this circular convolution in MATLAB, then we are going to use two different functions. For linear or regular convolution, conv is the function available in MATLAB, and for circular convolution or periodic convolution, cconv is the inbuilt function available in MATLAB. Here two input sequences are declared, x1 and x2. Both are having the length equal to 4. Now the length of resultant linear convolution will be equal to 4 plus 4 minus 1, that is 7. And the length of circular convolution will be equal to 4. So suppose if I want to calculate linear convolution through the circular convolution, then I have to adjust the length of both the sequences x1 and x2 exactly equal to the resultant of linear convolution. That means I want to adjust the length of x1 equal to 7 as well as length of x2 equal to 7 by adding the zeros in that. So this length adjustment is done at these two steps, two lines of instruction by adding the number of zeros. Now as the x1 and x2 lengths are extended, we can use the circular convolution instruction to calculate its linear convolution through the periodic convolution. Then the result is displayed here with the title as, with the label as linear convolution via circular convolution, and the result is displayed. Then by using the conv function, direct convolution or regular convolution, also called as linear convolution, between these input signals x1 and x2 is calculated here, and the results are displayed. Next to that, the periodic convolution or circular convolution between x1 and x2 is calculated for 4 points. Similarly, circular convolution between x1 and x2 for 8 points is also calculated. Now, we will verify the result in MATLAB software. Here, x1 and x2 input sequences are mentioned. Then, length of x1 and x2 are extended by adding the number of zeros. The lengths are made equal to the length of linear convolution resultant, that is 7. Then our linear convolution is calculated via circular convolution. Results are displayed. Next, linear convolution between x1 and x2 sequences is calculated. Next to that, circular convolution between x1 and x2 for 4 points is calculated. Then circular convolution between x1 and x2 for 8 points is calculated. And all the results are displayed. Now we will execute this particular code. You can see the result. Sequence x1, sequence x2, both are having the length equal to 4. Then by adding the number of zeros, the length of x1 and x2 are extended and made equal to the length of result of linear convolution. Linear convolution between x1 and x2 will be having a length of 7. So we can see that by using CONV function, if we are calculating the linear convolution, it is having 7 number of elements. Similarly, by extending the lengths of x1 and x2, and if circular convolution is calculated, that is also giving the same result. Then this is a result of circular convolution between x1 and x2 for 4 points, and this is a result of circular convolution between x1 and x2 for 8 points. Thank you.